Hello everyone, this is the first lecture for Embedded Systems Practical of MScIT Part 2. Here is the index of practicals. We have a list of 10 practicals. Out of the 10 practicals, the first practical is study of embedded system hardware components. This is a theoretical practical. There is no practical to be performed. However, one question may be asked about hardware components related to embedded systems. The rest 10 practicals are practicals that we will be performing. Now, this is a video lecture series to show the implementation of practicals on simulators. We would be using two simulators. The first simulator is Protus, that is used to simulate the hardware part, and the second part is writing the code. The simulator used is Keel. The following are the steps that will be used to perform the practical using the simulator. Once again, the simulators or the softwares to be used are Proteus and Keel. These are the steps that we will be using. The first step would be to create a design in Proteus. Once the design is saved, we have to write the code that will run in the design. To write the code, we first have to open a new project in Keel. So we would launch the Keel software and open a new project in Keel. Next would be to save the project in a particular directory or folder. After that, we save the project in the directory just created. The next step would be to select the microcontroller. So the microcontroller that we would be using is Atmel. Under Atmel, we use 8089C51. So once this is done, next step would be to write our source code file. Once we are done with writing the file, we would save it with the .c extension. Once we are done with this, we add the recently created C file to the project. Once this is done, we build the project to find if there are any errors or not. This step may be optional. We can check the execution of the code in the Keel environment. The next step would be to generate the hex file. Once the hex file is generated, this hex file generated over here is given to the design that was created in step number 1. After that, we test the circuit as well as the code as we run the program in the Proteus environment. We will start with the